through the power of the people of Minnesota, the Environment and Natural Resources Trust Fund is a key component of environmental protection here. I don't think there's any other state in the country that funnels so much of its resources into sustained funding, which allows the state to be proactive about issues of environmental concern. In the early 1970s, we had discovered fish from lakes in northern Minnesota that had some surprisingly high levels of mercury. This is particularly serious because we've known for a long period of time that mercury is a potent neurotoxin, posing a dietary threat to people who eat it, but also to fish-eating wildlife. The first question was, where's this coming from? We were able to establish through some initial studies that it was from long-distance transport of mercury from a variety of emission sources, local, regional, and global. So we started to ask the questions, why are we seeing these high levels of mercury in northern lakes? What's going on in our urban environment? What's going on in our agricultural landscapes? And how are they different? And so, starting in 1995, supported by the Trust Fund, we studied 55 lakes across Minnesota to reconstruct how mercury inputs had changed over time in these different areas. So you need some means of reference for change over time. This is where lake sediments come in.
1, 2, 3. We're interested in collecting the layers of mud at the bottom of the lake because they're kind of looking back in time. In this region, you'd probably need an average of 3 to 4 feet of mud to get back to the 1800s, which is what we were interested in doing.
That's a key period of time. The best reference we have is back before Europeans came in and cut the forests, plowed the prairies, built cities, started to emit pollutants through smokestacks. That gives us a baseline for what is natural.
So what we go out and do is take a polycarbonate tube, put it down into the mud. It's not super different than if you put a straw into a milkshake and added a little suction and pulled it back out. We call it a sediment core. Before they were even analyzing for mercury, each of those cores had to be sectioned in 1 to 2 centimeter increments and then brought back to our laboratory where technicians radioisotopically date the cores and then build models to figure out exactly how old that sediment is.
We ended up analyzing some 2,200 samples. It took us a couple years to finish both the field work and then the lab work. It had not been done on that scale before. One of the key things about the mercury study is it provided a baseline for Minnesota to develop a program to reduce mercury emissions. And since that time, the state has reduced its industrial and power plant emissions of mercury by something like 90%. As we were wrapping up the mercury study, we realized that we had a real gold mine of information here. Why not ask similar questions about other pollutants of concern?
One of the reasons the funding from the Environment and Natural Resources Trust Fund is so important is so projects can build upon other projects. These sediment cores that they had previously collected, they had archived all of their material, and I was able to then use that to look at fossil diatoms in the sediment cores, which are single-celled algae that make really excellent bioindicators. And so I could see water quality trends around the state of Minnesota over the past couple hundred years. I had 700, 800, 900 hours of microscope work that had to be done for this project. But I really loved it and how it would be useful for lake management. We learned quite a few things about fluctuation in water quality parameters such as total phosphorus, chloride, pH. A lot of lakes in the metro region and agricultural regions showed significant increases in phosphorus once European settlement started to make significant alterations to the landscape. The result of this project was the diatom calibration model. That allows us to say things like species A will be abundant when the phosphorus level is this, or species B will be abundant at a given pH level. Myself and colleagues at the St. Croix Watershed Research Station have continued to refine it. We use it repeatedly in projects for watershed districts and projects in conjunction with the DNR or the Minnesota Pollution Control Agency to figure out the best way to manage these lakes and keep them in good swimmable and fishable condition for everyone to enjoy.
I think that Minnesotans can see the results of these kinds of projects. If you were able to point to them and say, your trust fund dollars went for this project, people would say, yeah, I'm very proud of that.